Question 1.3. Determine the equation of altitude BE. So here is BE. What is BE? So BE is simply a straight line. So, in other words, determine the equation of straight line BE. What do we need in order to determine an equation? We need the gradient. We need the gradient. So, what is the gradient of BE? Can we work out the gradient? Do we have 2 points? y2 minus y1, x2 minus x1. The problem is we do not know the coordinates of E. But we know that BE is perpendicular to AC. Okay, so let's write that down. BE is perpendicular to AC. That was given. So what does that mean? It means the gradient of BC, sorry not BC, the gradient of BE multiplied by the gradient of AC must equal to minus 1. Those are perpendicular lines. Let's write that down. M1 times M2 is equal to minus 1. The gradient of line BE times the gradient of line AC is equal to minus 1. What is the gradient of line BE? That's what we want. What is the gradient of line AC? Remember, we were working out the angle of inclination in the previous example 1.1. Sorry, that was 1.2. 1.2. So we already worked out the gradient of AC. Okay. So M of BE times M of AC. Let me just double check if that is correct. So 3 plus 5, that's 8. Minus 2 is minus 4. 8 divided by minus 4 is minus 2. Let me just double check on my other board. Yes, M of AC was minus 2. We did work it out. So times minus 2 is equal to minus 1. So therefore, the gradient of BE is going to equal to minus 1 divided by minus 2. A negative divided by negative will be a positive 1 over 2. Right, so therefore, I'm going to use the equation of the straight line point gradient form. I want the equation, remember I want the equation. So I'm going to go y minus y1 is equal to m into x minus x1. Right, so I'm going to go y minus yb is equal to m of be into x minus x of b. I'm just being more specific. We have a point on the straight line. All you need is 1 point. If you have 1,000 points, you choose any one, it must work. So we have a point and we just worked out the gradient. So now y minus the y value at b, so therefore it's going to be y minus 2 is equal to the gradient of be, which is 1 over 2x minus xb, so that's going to be x minus the x value at b, which is 3. So therefore, y minus 2 is equal to half times x, which is half x, and half times minus 3 is minus 3 over 2. So y is equal to 1 over 2x minus 3 over 2 plus 2. So therefore, y is equal to 1 over 2x minus 3 over 2 plus plus 4 over 2. So y is equal to 1 over 2x. 4 minus 3, that is 1, so that's plus 1 over 2. Right, so that was our 4 marks. Determine the equation of the altitude BE. The next question, determine the coordinates of E. Okay, now we need to work out the coordinates of E. So E lies on line AC. It also lies on line BE. So E is an actual point of intersection. Let's write that down. E is a point of intersection of lines AC and BE. Right. Now, point of intersection, solve simultaneously. Now, we have the equation of BE. We just worked it out. This is the equation of line BE. So all we need is the equation of line AC. And then we can work out our points of intersection. So AC, let's write down line AC. So what do we know about the gradient of AC, which we already worked out before, was where AC is minus 2. Alright, let's take a point. Let's use point A. Let's use point A. A is minus 2, 3. So I'm going to go y minus y of A is equal to m of AC into x minus x A. Same formula, y minus y1 is equal to m into x minus x1. So now we have y minus 3 is equal to minus 2x minus xa minus that will be plus 2. So therefore y minus 3 is equal to minus 2 times x is minus 2x, minus 2 times 2 is minus 4. So now y is equal to minus 2x minus 4 plus 3. Y is equal to minus 2x minus 4 plus 3 is minus 1. Let's check. This is line AC. AC obviously it must have it's going down, negative gradient AC, and the y-intercept must be negative 1. And remember, M was the midpoint and the y-intercept, the y value of the midpoint was negative 1. So we confirm that with the y-intercept of the straight line is also negative 1. Right, so we got this one and solving simultaneously now. So what do we have? We have y is equal to half x plus half, and we have y is equal to, the other equation was minus 2x minus 1. Okay, so we solve simultaneously. These are linear equations. You can use the method of substitution, substitute one equation into the other, or use the method of elimination. It's up to you. Let me use substitution this time. So I'll take this equation, replace it here, so I've got half x plus half is equal to minus 2x minus 1. Right. Let me get rid of this denominator 2 here. Let me multiply by 2 on both sides. 2 over 1 here, 2 over 1 there. Whatever I do on the left, I do on the right. That will be 2 and 2 cancel, that will be x2 and 2 cancel, plus 1 minus 2x times 2 is minus 4x, and minus 1 times 2 is minus 2. So I'm going to get x plus 4x is equal to minus 2 minus 1. So we got x plus 4x, which is 5x is equal to minus 3, so x is equal to minus 3 over 5. So therefore, y must equal to, substitute here, going to any one of the original equations, and let's see what we get. So I'm going to substitute y minus 3 over 5. Let's see what we get. So y is equal to 1 over 2 times minus 3 over 5 is going to be minus 3 over 10 plus 1 over 3, which is equal to LCD there will be 30. So yes, the LCD will be 30 there. That's going to be minus 3 times 3 plus 1 times 10 over 10 times 3, which is going to be minus 9. Minus 3 times 3, let me just write that down, is going to be minus 9 plus 10 over 30. So 10 minus 9 is going to be 1 over 30. Okay, so therefore, E, coordinates of E, we got minus 3 over 5, 1 over 30. But remember to double check. Always double check it. Check both equations. And I just noticed my mistake here. When I substituted, it's half x plus half. And I got half x plus 1 over 3. So the mistake is here. It's supposed to be a half. That's what's wrong. So this is not 1 over 30. Okay, that's why it's important to substitute into both equations, so you check, and then you can always correct it. So this becomes minus 3 over 10 plus 1 over 2. So my LCD will be 10. So all I will do is multiply by 5 there, 5 there. So I'm going to end up with minus 3 plus 5 over 10. Minus 3 over 10 plus 1 times 5 is 5 over 10. 5 minus 3 will give me 2 over 10. And 2 divided by 10 is the same as 1 over 5. So this was a 1 over 5. Let me just double make sure now. Just to show you what happened here. Let me substitute into the other equation. Y is equal to minus 2x minus 1. So that's going to be minus 2 times x minus 1. What was my x? My x was minus 3 over 5. So let me substitute my minus 3 over 5 there. Right, so I'm going to get 2 times minus 3 is minus 6 over 5 minus 1. What is 1? 1 is the same as 5 over 5. Minus 2x minus 1. Sorry, minus times minus is plus. 6 over 5 minus 5 over 5 is 1 over 5. Alright, so you can see there's a lot of working out here, and we need to be careful with our signs. That's why it's important to go back and with simultaneous equations substitute into both equations to make sure. that your answer is correct. The last question here. Calculate the area of triangle ABM, not ABC. ABM. So remember, M was the midpoint. Go back to your diagram. AB, remember M. So here, what do we have? We have AB, and then we have M. So this is A, that's M, and this is B. What do we know? We already know the angle A. Angle A is 52,1 degrees. Okay, now this is side A, this is angle A, so this will be side A, this is angle B, side B, angle M, side A. Okay, so now the area formula. Area is going to equal to half. If we are taking these two, BM, then it's going to be times sine A. Or area is equal to, if we're taking these two sides, it's going to be AB, then it's going to be sine of the included angle. So the angle, it's side, angle, side. The angle must be included in between the two sides. Or area is equal to, if we're taking these two, AM, these two, and this will be the included angle, sine B. Now, we will not use this one or this one because we do not have angle M, we do not have angle B, we do have angle A. We do have AB. Remember, we worked on AB, there's AB here. AB is the square root of 26. So we got this, we got M, all we need is to find this side here, AM. Okay, so A is minus 2, 3, and M was 0, minus 1. Remember, M was the midpoint there. So if I want the distance from A to M, it's going to be the square root of x1 minus x2 minus 2 minus 0 squared, y1 minus y2, 3 minus 1 will be 3 plus 1 all squared, and that's going to be minus 2 squared, which is 4, 3 plus 1 is 4 squared, which is 16, so we got the square root of 20, which can be simplified further, but we are not interested in the simplification. Okay, so now we found that this is square root 20. So therefore, area is going to be equal to half that side there, AM, which is small letter b, times small letter m, which is AB, times sine of angle A. Remember, AM is the same thing, small letter b, AB is small letter m. It's up to you how you want to write it. Okay, so area is equal to half AM, AB, sine. What is AM? The distance of AM was square root 20. AB, what was AB? AB, where is AB? Square root 26. We worked it out earlier on. Sine of angle A, what was angle A? 52,1. Let's work it out. So we got half times the square root of 20 times the square root of 26 times sine of 52,1 angle in degrees. So we get 8,99694. Right, so basically if you're rounding up to one decimal place, okay, let's not round up to one, let's round up to 3 decimal places here. So that's going to be 8,997. units squared. That is the area.